Measure airflow cubic feet per minute like a pro in seconds with the heating, ventilation, and air conditioning temperature rise formula to confirm whether your system's cubic feet per minute matches its tonnage target for comfort, efficiency, and humidity control. If you are heat mode only, use the steady state temperature rise method. Take supply air temperature minus return air temperature with a fast response thermometer. Note furnace input and measured electrical power, then compute delivered heat and back calculate cubic feet per minute. For cooling, use sensible heat capacity by measuring dry bulb split across the coil plus total electrical power to estimate sensible capacity and convert to cubic feet per minute. Target airflow per ton is usually 400 to 450 cubic feet per minute in cooling climates and 350 to 400 in humid climates, but verify the manufacturer's table because some variable capacity systems want 300 to 500 depending on dehumidification mode. Always stabilize for 10 to 15 minutes before readings, measure at least 3 points in both supply and return plenums, and average to reduce stratification error. Correct for altitude by adjusting air density and correct for electric heater strip heat if present because it inflates the temperature rise. If static pressure is high, bias readings by taking temperatures far enough from the coil and heat exchanger to avoid radiant influence, and use a pitot traverse or a well-calibrated hot wire probe if you need tighter accuracy. Cross-check airflow with total external static pressure plus the blower performance table. Do not trust temperature alone when coils are partially wet or dirty. Document line voltage, blower tap or percent, filter model, coil cleanliness, and damper positions, so your airflow calculation is reproducible. One of the most common airflow problems in heating, ventilation, and air conditioning systems is undersized return air, causing low cubic feet per minute per ton, which shows up as high total external static pressure and a larger than normal temperature split. Fix it by adding return grille area, opening blocked dampers, using deeper media filters with lower pressure drop, or adding a dedicated return. Another frequent issue is duct restrictions from crushed flex or dirty evaporator coils that limit cooling capacity and raise humidity. Verify by comparing static pressure before and after the coil, and by inspecting flex, bends tighter than 1 duct diameter radius. Then straighten flex, add metal elbows, clean the coil with manufacturer-approved chemistry, and remeasure. A third common mistake is running the blower too slow in cooling mode to chase dehumidification without watching coil temperatures, which can cause coil icing and poor airflow. Set blower speed according to the manufacturer's airflow per ton table, confirm superheat and subcooling are on target, and use the variable speed dehumidify mode only with an installed and configured humidity control that limits reduction to about 10% from nominal cubic feet per minute. BigHomeProjects.com lists vetted heating, ventilation, and air conditioning contractors who can measure airflow cubic feet per minute with the temperature rise method. Total external static pressure and blower tables, then make precise adjustments like blower speed changes, duct corrections, and return sizing. Homeowners use the directory to compare verified reviews and licensing, while contractors gain steady work from quality leads and showcase expertise in airflow balancing, comfort optimization, and humidity control.